So we are going to be talking about some really cool stuff this evening. We're going to be looking at some research. Those that know me know that I'm big on research. I actually spend a lot of my time actually reading research studies so I can find out what's going on within our space. Now, personally, my greatest area of interest tends to be in areas of human learning, social development, those kinds of things. And I spend a lot of time reading that kind of research. But I spend a significant amount of my time reading the latest research on, of course, wireless technologies, because that's where you find out what's coming. You can pay attention to standards development, which is, of course, key in what is coming around the corner in the wireless space and in networking in general. But the reality is to really have your finger on the pulse of what's coming down the road. You've got to look at the research that's being done. And there is actually a lot of scientific research published in the journals on wireless technologies and advancement in wireless technology. So if you are kind of new to the space and you want to dig deeper into that, I would really encourage you to pay attention. We've talked about in other live streams and in other webinars. MDPI is a great place. ArcSiv. There are several places you can go to find the latest research. And what it usually is people testing either through simulation or through prototype devices, the various technologies that are coming and how they're going to work and what works best. And you can learn from that a lot of important knowledge on how to fine tune the solutions that you'll be developing. But tonight for the live stream, we're going to talk, first of all, about such a research project. We're going to look at this thing called RAID. No, it's not redundant array of inexpensive or independent disks, depending on whose definition of RAID you look at for drive storage. But instead, this is a root cause anomaly identification and diagnosis. It's a research project that gives us some really useful things to learn how machine learning can be used to monitor network environments and to gain alerts when there are problems in those environments. Then we're going to dive into learning with large language models and some of the research that's come out over the last year, particularly on that. And then we'll give you a little sneak peek at Friday's webinar, actually, where I'll be showing you how to get LLMs to go deeper for you into the knowledge base that you might want to explore. And then, of course, we'll have our news roundup, and we're going to start a new thing this month where we're going to just mention briefly at the end a podcast that is useful or beneficial in the wireless space. And so we'll make sure we cover that as well. As always, for our monthly live streams, we have the notes for you at the CWNP blog. They are already there. And I will add to those notes the actual video link as well to the live stream once we have that available. And that way you'll have everything in one place. So we're going to go, first of all, into this issue of the root cause anomaly identification and diagnosis. And how this is being done is through data gathering and machine learning. And so, Jonathan, one of the things that people talk about a lot is how do we use AI and what is the future of AI and how do I best employ AI? And it's funny because over the last year and a half to 3 years, I have noticed that people seem to forget that we've had AI for decades. We have not had, obviously, general artificial intelligence, and we still don't. But we've had AI. We've been using machine learning for a long time. And I don't know if you've noticed this, but people seem to forget about machine learning all of a sudden. And they think everything needs to be LLMs or generative AI. And they are ignoring that, what we already had might be the best solution to your problem, rather than assuming we need to always use this new generative AI stuff. Have you run into that too, noticing that there seems to be less focus on what's tried and true and more focused on what we don't really know whether it's going to work or not?
No, 100%. Just the more updates that come out, all the different iterations, all the, be honest, the cash grabs, right? Is it cool? Does it do reasoning? I'm trying to develop new prompt engineering when in reality, like you said, it cuts through data very, very effectively. It's going to spit out solid results and give you a good baseline. And I mean, it saves me time all the time. So I'm with you. Like I'm trying to go back to basics and make sure I utilize it where it's strongest. I said at that machine learning algorithm.
Yeah, exactly. And here's the thing. There are a lot of tools already. There are libraries for Python that can implement all kinds of different machine learning algorithms. There are modules for the R programming language, and that can be used in RStudio to do ML-based data analysis. You know, there's just a lot of this stuff out there. And so assuming that, oh, we've always got to use this new thing that's shiny, whereas the reality is a specific algorithm that has been designed for that purpose may very well not only do a better job for you, but be more accurate in the end. And so this research that has been done in this case, it is focused on using machine learning. And you can find the research. The URL, of course, is in the blog post, so you can follow the link. And what they're doing is they're looking specifically at Wi-Fi networks and how we can gather data about these Wi-Fi networks and then use machine learning to analyze that to look for problem areas and try to find solutions. And so when we look at the actual PDF of their research paper here, then you can see, again, the RAID comes from root cause anomaly identification and diagnosis. They are focused on Wi-Fi networks. They're focused on a specific latency sensitive application of cloud VR. And they're looking to improve quality of experience. And they're doing it through root cause diagnosis and machine learning. So this is what the paper's about. I'm not going to read it all to you. You know, you can read it at your own leisure, but I do encourage you to come in and skim the paper. If you start going through it and you get to a point where you say, oh, I don't understand what that's talking about, well, don't worry too much about it, because I'm going to explain something to you. Because as you do get down into the paper, you're going to start seeing things like what we have right here. You know, given a data set, D train equals W1Y1 to WTYT. And as soon as some people see that kind of thing, they immediately eyes glaze over. They think, I don't know what that means, and I don't want to find out what that means. Well, here's the thing. Two things. First of all, remember, while I just spent a significant amount of time saying we don't need to use generative AI for everything, here's a good example of where you could. You know, you could upload this PDF to ChatGPT, Gemini, whatever, and then say, hey, can you explain the formulas in this paper to me? And it will help you understand those concepts. But one of the great things that I like specifically about this paper, and the links for both are in the blog for the show notes, is that they have a matching GitHub repository. And this GitHub repository for this research gives you the data sets. So you can actually download the data sets and do your own analysis against it. But it also gives you the scripts. So if we go into the scripts section of the repository, you can see here, these are some Linux shell scripts. And if we go into the experiments, we can see Python scripts. And if we go into the utilities, we can see more Python scripts. So here's the point. When you're going through the paper, you're going to see formulas. And some of the formulas do get a little bit complicated and convoluted. You know, they've got multiple nested summations and all kinds of things that make a lot of people want to run away screaming. And I found this in another area over the years. So, you know, I started teaching security concepts probably around 1998 or 1999, somewhere around there. And encryption is obviously something that you have to teach. And I find that most people struggle when learning encryption because the math is so confusing to them. And that's the point where they often walk away and say, well, I'll just give up and I'll just know, okay, good enough. I have data I have a key. I have an algorithm that does something with that data in that key. And that's good enough for me. I don't need to know the rest. And what I've found is that while if you show people the mathematical formulas that the encryption algorithms use, they run scared. But if you show them source code that implements that formula, they seem to be able to grasp it. They can understand it better. And I think there's a reason for that. I don't think our brains think in those mathematical formulas. I think they process things more sequentially. And we think, okay, what's step 1, step 2, step 3? And then maybe there is a loop there and we go back and do some steps a few times. And that's what source code does. So source code walks you through the sequential process. And when it does math, unless you're using some library that abstracts it, when it does math, it does simple mathematics like addition and subtraction and multiplication. And you're doing these in sequences to build up to those fancy formulas. And so you can understand what's actually taking place. So I have found a lot of times, if you can see source code that actually implements this fancy algorithm, you can understand it a lot better. What do you think about that?
No, 100%. Just in terms of understanding encryption, understanding how we can break all that down. I'm a big fan of that sequential, step-by-step, loop it, just from learning in some recency, going through wireless concepts that can be very, very cumbersome, very difficult. So 100%. As long as I can get it down to the source to understand how it got to the result and then fill in the blanks, without a doubt, that's the way we should be doing it.
Yeah. And so it's funny. What I used to do is, and I still do this, if I'm teaching encryption in a wireless class or something, and I can sense I've got some people there that really aren't grasping the fundamental concept of how it works, I actually take it down to a very simple level, and I do basic math. And I show them a basic math algorithm that you can use variables within that algorithm and generate a value, an integer output. And then you can take that integer output and reverse the algorithm using the variables again and get back to your original data. And I show that if you know the value of variable K, the key, then you can reverse and get back the original integer input that gave you your integer output, because you know the algorithm. And so with encryption, the algorithm is known, the key is unknown. And that's the whole mystique of it. And so if you can show them a simple thing like, 5 plus 3 times K equals output, then obviously you can reverse that and get back to your original 5. If you always take 5 plus 3, that's the first thing you do. You take your input integer 5 plus 3, multiply it times the value of K, that gives you your output. Simple math, right? I can reverse that, but I can only know that 5 was my original thing if I know that the key is right. In other words, I can always get 5, but I don't know that 5 is true unless I know my key is right. So when you show it using simple math, basic algebra, in other words, when you show it using that, then people say, okay. And then you say, okay, so now computer encryption is simply this on a binary level with a more complicated algorithm. And so then all of a sudden the light bulb comes on and they say, oh, so encryption is just algebra. Yep. That's pretty much what encryption is. And when you understand that, then it takes away the mystery. And when the mystery is removed, you're willing to dive in, and because you now believe you can learn it. The thing that keeps most people from diving in is they don't believe they can learn it anyway. Oh, that's for those smart people. I wouldn't be able to figure that out.
Right. It's that wizardry. Yeah. And I think once you grasp even that concept, it can steamroll. Like I know for me that symmetric, asymmetric key was a big piece of that. And then it got me into thinking, oh, then there's key management. That's where data can come in, and how much data and how much compression you want to do with that. So it can really snowball very quickly, which is nice. I think that's something everyone can and should get motivated with. Like once you kind of have those aha moments, it really is exponential, and can get you where you want to go from a learning aspect.
You know, it's like I've told people a lot of times, nothing is complicated as long as you can break it down into very small component parts and then understand each component part. So in other words, it's only complicated because we say, oh no, there are 75 component parts I need to understand. I don't want to have to understand those. Well, that's just an issue of I don't want to put in the time to do it. It's not an issue of I can't do it. And so a lot of times what people define as too complicated for them to be able to understand means too complicated for me to be willing to spend the time to understand it. and in fairness, that is reality. Sometimes we don't want to spend the time. I don't want to spend the time to learn absolutely everything about all the components in a computing system. I want to instead say, hey, give me a library that does this. Or give me a piece of hardware that does this. And someone else has to build that piece of hardware. That's just fine. And that's the reality of how we live our everyday lives. We can't know everything about everything. But when it is something you want to know about, then obviously you need to break it into those component parts. So I only brought up this particular research this month because I feel that it gives you something extra. So if you have been looking at machine learning and you've wanted to know more about it, this is a great way to bridge that gap with Wi-Fi and machine learning, have some actual data that you can explore, have some actual scripts that you can look at and understand how they work while reading through the paper. And I think this can take you huge leaps forward in understanding the use of machine learning with wireless monitoring and things like that. Really, really cool paper and project. Which brings us into our second topic, and it's what we've kind of already been hinting at about learning and breaking things apart. I came across one paper, I believe it was this one at MDPI, on exploring the impact of LLM prompting on students' learning. I believe that was the one, but I came across one paper, and that made me dig deeper. And I said, okay, I want to know what other research has been done over the last year or so on this, because we've had large language models for several years now. It's hard to believe, but I mean, maybe someone younger like you, Jonathan, it doesn't seem like a short amount of time, but when you get older, bigger chunks of time seem shorter. And it literally seems like just yesterday we got the first release of ChatGPT and people were saying, oh my goodness, look at this cool thing. But it has been several years ago now. And it's given us time to begin to explore how these things can be used. And I've watched a lot of people trying to use them to learn, to get information, to get explanations. And, you know, sometimes all we want is the definition of something. You know, maybe you're watching a documentary, or maybe you're watching some YouTuber and they use a term and you think, what does that mean? You know, and hey, large language models are great for just what is, and then you give it the term and have it explain it to you. And I've found that nowadays they're pretty accurate most of the time. But when you want to learn, really learn, that simple, direct prompt is generally not the best thing that I've found and experienced. And so I was really excited to see that there's actually research into this that is showing the best ways to use large language models, to interact with them. If you are an educator, how to help in scaffolding the learning process using large language models. There's a lot of really good insight into this. And obviously, you know, we're not going to go into every detail that every one of these papers has delivered, but I did find it really interesting, a few of the key things. So this first one here, which again, remember, the links are in the live stream notes, says impact of guidance and interaction strategies for LLM use on learner performance and perception. And, you know, one of the things that they went into here is what are the different ways that people interact with the LLM, and how does it assist them in the learning process. So in this particular case, they looked at what are the specific effects of common guidance strategies. And the guidance strategies they mention are providing instructions, presenting examples, employing metacognitive questioning, and encouraging initial problem solving with subsequent refinement on the learning process supported by an LLM tutor. Now, we'll see this come up again in a couple of the other papers. Well, we might not see it, but it's in the other papers, particularly this one on metacognitive questioning. And so I want to talk a little bit about that. There's something in the research literature on learning that if you can improve a student's metacognitive skills, then you will improve their ability to learn anything. So whatever it is you want to learn, one of the best things to do is to make sure you know how to learn. That's metacognitive skills. So metacognitive skills really fall into three categories in the history of the research of this. They've kind of narrowed it down to three categories, which are planning, monitoring, and evaluation. So planning basically says, before you start learning, you stop and think about how you're going to go about learning. Putting this in as simple of terms as I can. So you're basically going to say, how am I going to learn this? Am I going to use books? Am I going to use websites? Am I going to use YouTube videos? Am I going to get hands-on experience? What is my plan? Planning your learning. That's the first metacognitive skill. The second one is monitoring. So while you're doing it, you're asking, do I understand this? Because one of the biggest mistakes people make is they read something, they don't understand it. They know they don't understand it, but they just keep right on reading anyway, because they're supposed to read 50 pages. That's what they're trying to do. Right. But the problem is, by the time you get to the end of the 50 pages, you forget what the stuff was that you didn't understand when you read it. And so now if you're going to address that, you've got to go back and reread everything to find the stuff you didn't understand so you can know what you need to look further into. So metacognitive monitoring says, I'm going to note right now while I'm in this process that this is an area that I'm not understanding. So you're monitoring and you're documenting. Think about the RAID process we just talked about with the monitoring of the environment. You're looking at certain metrics like received signal strength indicators, or what is the MCS for the data link, or whatever. So you've got particular things that you're monitoring, and then you're looking at what you've monitored and asking, is there a problem? Well, in the same way, metacognitive monitoring is I'm continually analyzing my comprehension as I'm going through the learning process, and I'm documenting if I don't understand something so that I can learn about it better later. I'm asking if I'm on the right track. So maybe I designed a learning plan and I figured out halfway into it that I'm not even learning what I need to be learning. I've picked the wrong tools. I've picked the wrong process. And of course, you're also, one key thing is you're monitoring your energy level, your motivation level. And I don't necessarily just mean, am I sleepy or alert? Am I tired or not tired? I'm talking specifically about your energy for the learning. Mm-hmm. You can be alert, you can be not tired, but not caring less about the thing you're supposed to be learning about, right? And so you'd rather go watch a ball game, you'd rather go for a walk, you'd rather do anything than what you're doing right now. And so then you step back and say, I don't have the energy for this. So either I rest it for a while and come back to it later, or I use some methods to re-energize myself. So that's the metacognitive skill of monitoring. And then the last one is evaluation. And that is, okay, I'm done with the learning process. And so now I'm asking, did I achieve my goal? What could or should I change in the future when I go through this process? What excites me most about what I just learned? And how will I implement it or use it? And where do I go next? So again, the three areas are planning, monitoring, and evaluating. And so the big question they're looking at here is, with metacognitive questioning, are you interacting with the LLM in such a way that you're actually thinking about how you're interacting with the LLM? Or are you just chatting? Are you just prompting, whatever the first thing that comes to mind. So metacognitive analysis would say, I'm going to step back at a higher level and ask, before I put my prompt in, is this the best way to prompt it? Is this the direction I need to go? Am I thinking right? Or am I just blindly going with whatever my first impulse is? That's metacognitive ability. And all the research shows that people that have high metacognitive skills do much better in learning and in academic achievement and even in life achievement. But, you know, the biggest reason for that is part of self-regulation, right? You're evaluating what you're about to do, what you're about to say, and you're asking, is it stupid to do or say what I'm about to do or say? Or should I do something else, right? So when you have that self-regulation to pause and reflect, you end up doing better. So that's what this one brings to the table. I'm not going to spend more time on that one. This one deals with the leapfrogging effect, generative AI as a permanent scaffold in higher education. So in the world of education, scaffolding is, well, it's a metaphor borrowed from what we see in construction, right? So if you see a building being built, someone's got to get up to a high level. They build this temporary thing called a scaffold that is there while they need to get up to those high levels to do what they need to do. But it's temporary. It's a temporary support that is intended to be removed at a later time. It's the same thing in learning. So early on, we give these aids or assistance. And so you can think of if a teacher comes up and prompts you and says, okay, what if 4 plus 2 is 6, then what would 4 plus 3 be? That would be the teacher scaffolding your learning by helping you think down a path that helps you to get to the destination you need to get to. Eventually, they remove the scaffolding and you're expected to be able to do it on your own, right? So that's the concept of scaffolding. And an educational philosopher named Vygotsky came up with this concept of ZPD, the zone of proximal development. And basically what it is about is saying there's a boundary around what you can expand your knowledge or your learning on your own. And you will need help to get beyond that. So somebody that has the right knowledge to take you to the next level, for example. And that plays into all this scaffolding concept as well. And what this paper is arguing is, hey, maybe, just maybe, large language models can be a permanent scaffold as you're going through the education process, meaning that it's always there for whatever way you need to be scaffolded at the time. But in order to do that, you have to interact with it in the right way so that it's a scaffold and not a crutch. And what I mean by that is, if, for example, I'm always just asking the AI to do my work for me effectively, then it's a crutch. It's not a scaffold. And so it's up to me to say, I really want to learn. I want to understand. I want to do better. It's up to me to do that. And so therefore, I'm the one that's got to interact with it in a way that enhances my learning instead of interacting with it in a way that just gets me to the end result faster so I can move on. Learning is never a fast thing, right? Learning is it has to be a slow, methodical process. Now, when I say slow, I don't mean slow as in everybody does it at the same rate and it has to take you years to learn something. I'm simply saying that when you've got a tool like large language models that can spit out the answer to a question in a heartbeat, obviously learning the reason that answer is correct takes a lot longer than just getting the correct answer. That's what I'm after. So learning takes time and you've got to use it as a scaffold. So that brings us to where I really want to get with all this that I've been building up to, is they have here this paper. By the way, the last one was from March of 2025. This paper is from June of 2025. Interestingly enough, by the way, the most important day in June, June 24th, that's the most important day, not only in June, but it's the most important day in every year. Do you know why, Jonathan?
Do not know why. Would love to learn. Yeah.
To me, I'm saying that's the most important day every year. What is it? It started being the most important day in 1972, and it has been ever since then. Any hint as to what that might make it?
1972.
I'm 53 years old, if that helps.
Oh, yeah, that would be your birthday.
Exactly. So June 24th, 1972, that began being the most important day of the year to me, just like for everybody, you know. Their birthdays
I did want to
both.
believe that 1972 was your birthday year there, Tom.
Thank you. I
Yeah.
appreciate that.
1990.
All right. So this paper is called Dialogic Pedagogy for the Large Language Models, Aligning Conversational AI with Proven Theories of Learning. Anyone who knows Tom Carpenter knows when he sees a paper titled like that, he's going to read it. I love learning, and so you link learning to technology, it makes me even more excited. So when we go down through here, there's a lot of literature review on different learning concepts and theories and styles and so forth. And then eventually we get down here to where they get beyond the theory and they give you a nice summary of it all. So conversational agents can provide effective support for learning across many contexts. Challenges and limitations are consistently noted, like regarding the accuracy and reliability of the responses, ethical concerns like plagiarism when you're writing a college paper, and the need for pedagogical oversight. And AI is only as good as its design and the context in which it is used, or the guardrail. Excuse me, the guardrails we employ. Researchers are trying to fix all this. Okay, that's the issue there. Then they get into different things like the Socratic method. So, you know, you can ask the LLM to question you instead of you questioning it. That would be an example of using the Socratic method with it. Vygotsky's sociocultural theory and the zone of proximal development, which we already talked a little bit about explaining what that is. The conversational framework of Larillard, the dialogic teaching and collaborative inquiry. So they get into a lot of these. Now they explain all the complicated stuff in this one. So you may or may not want to read this one. I encourage you to, but if you jump to the next one, they take all that complicated stuff. They just get right down to the nitty gritty and they say, here's how you do it. The impact of LLM-based scaffolding on academic performance. Interestingly enough, this is a conference paper that is to apparently be published sometime in the next year. It says the year for the conference is 2026. If you take, though the link is not here in how, if you highlight this and copy that and then paste it into Google with PDF at the end, you'll find the actual paper. And then there's another paper that is very similar in title that was published in May of this year, exploring the impact of LLM prompting on students' learning. And this final one here, this is the one, this is at MDPI, as everybody knows, one of my favorite sources of research. This one gives you a really, really great simplified overview. So it brings it all home. It tells you, all right, prompting strategies. Now, this one is really of interest to people in IT because this is a research project done with programmers, seeing how programmers use the LLM. And they gave an example of 5 different types of prompts: reflective prompts. I'm going to zoom in on this. Reflective prompts, debugging prompts, code-centric prompts, step-by-step guidance prompt, and direct instruction prompt. So the direct instruction prompt is like, hey, AI, generate this code for me, like an entire application or something, right? And then step-by-step, hey, AI, tell me the steps that I would need to go through to do X or Y. And then a code-centric prompt, hey, AI, write a function that does this. A debugging prompt, hey, AI, here's code. It's not working. Explain to me why. And then a reflective prompt would be where you're getting the AI to ask you to explain back to it how a certain code works or how you would code a certain thing, something of that sort. So these are the kinds of prompts. And what the researchers showed much pain over was that when they tested how people were using it, the lowest used prompting types were the most beneficial types for learning. And by the way, this was people in a computer science degree programming or a computer science degree program, specifically using LLMs to learn programming. So they were supposed to be learning programming, and they were using the kinds of prompts in most cases that do not help you learn programming, but rather have the AI do the programming for you. The best that they used was this step-by-step guidance prompt, where you saw here 34% of people use that. So that was the one that they used the most, that was the best learning prompt, but that's just kind of an average in the middle learning prompt. The best prompts for learning are reflective and debugging prompts. And yet they were, as you can see, the two of them combined were under 1% of all prompts. So people weren't using the LLM in the way that is best to use it to actually learn. Instead, they were using it in the best way to get done. But think about it. Isn't that what you do in your job? That's what you do. So all they're doing is kind of using it the way they'll use it when they get to their job. But in school, we've got to use it to learn. And that's what we're focusing on here for this period of time, is how do I learn with a large language model? And the key thing I think we can take away from this is, don't ask it to do everything for you. Ask it how to do things.
So I feel like that's big. I mean, do you think that's something that, well, I mean, we do research, you put guardrails, you can build up your own GPT, your own LLM, your own chatbot, but to that point, making so you can't prompt it for that, making so it is integrated like that. I mean,
I do think that's where, a lot of these research studies, they're suggesting to colleges and universities that they tell people they can use AI for their school projects, but that they have to use this particular one that is made available within their learning management systems that has guardrails around it that forces them to use it as a learning tool instead of just a do my homework tool. And I'm mentioning college, but K-12 is really struggling with this right now as well. They're struggling with students that are basically, using ChatGPT and just putting the question into it that's on their online test that they're taking, and then getting the answer from ChatGPT. And teachers are the way teachers are noticing that they're using ChatGPT is because their answers are so good. It's like they're giving an answer a 20-year-old would give, and they're in third grade,
Yeah, that's
So
true.
those kids need to learn to prompt. They need to say, answer this question like I'm a 10-year-old.
Yeah, exactly. There's levels to that, and I think I do think there's always easier corrections than we give them credit for too. Just it's not necessarily more work, but have the student explain things, have less traditional write it out, bubble in answers. If you can explain it on a piece of paper, write it out, then you know it, or at least you can see where that work is versus kind of that ease of grading, ease of just putting it in and getting that result, that output. So I think there's room for that as well.
So this paper is really worth exploring because it'll help you better interact with large language models. So if you come down a little bit further, you'll see right here's where they get into the different prompt types. So here's the direct instruction prompt, the one that people do the most of. They say it's the most frequently used strategy, accounting for about 60% of the student prompts. If you think of this in the terms of Bloom taxonomy, it's lower order thinking. It's the first two levels of Bloom's taxonomy, which is basically very fact-based, remembering and understanding. And it's not where, so let's say you want to work in the technology sector and you're moving into that realm. If you want to make the big money in the technology sector, you're not going to be a Bloom's taxonomy 1 and 2 person. You've got to be minimum of a 3, but really a 4 and 5 level person. That's a person who not only is able to go beyond just remembering and understanding, but as you come down here further, you will see in the reflective prompts that they're going to the analyzing and evaluating, but even more so, the debugging prompts, I think, is where they mention it. Understanding, okay, if I'm not seeing it, there's one of these they mention creating. So it's like the ultimate level, right? You're coming up with the new. And if you're going to be paid, it means you're going to that engineering level. And at the engineering level, you can't be the person anymore that can follow instructions in vendor documentation and configure something a particular way. That's Bloom's 1 and 2. Analyzing would be, okay, now I can analyze why when I do step 7 in the vendor documentation, it doesn't work, I can analyze why it doesn't work and come up with a solution. And that's fine. Now you're that mid-level professional. But when you want to go up to the senior level, the engineering level, the multiple six-figure level, if we want to call it that, whatever you want to call it, when you're going up to that next level, you're going up beyond analyzing to this evaluation, engineering, and even ultimate level, the creative level, where you're coming up with new concepts and ideas that no one else has developed before. That's where you bring the highest value. So the key then is, how do I use the LLM to drive me to those levels, to get me to that point? And these different prompt methods they're talking about can help you with that. So direct instruction prompts are, again, down at the lower two levels of Bloom's taxonomy. They're not really the best for learning. Step-by-step guidance is a little better. Only 34% of the people use that. Code-centric prompts are like the worst. It's write a function that does X or Y, and it really doesn't help you get up to the higher levels. Reflective prompts and debugging prompts are the two best. So reflective prompts are, why is supervised learning better than unsupervised in some cases? What are the pros and cons of using decision trees? Others ask, what are the different ways to connect a database in C#? What database type is best for a small inventory system? So in other words, they're looking at context, and they're asking to think about those contexts and how those contexts apply, which takes us up to the analyzing and evaluating stages. Then they point out, however, it's noteworthy and concerning that only a small percentage of prompts fell into this category. And then the debugging prompt, of course, is things like, why am I getting a value error in this Python model? And how do I fix this scikit learn import error? And why won't my SQL query insert data, etc.? Obviously, this is talking about programming, so all the questions and prompts are programming related. And it's indicating that, similar to troubleshooting prompts, they were relatively rare. So the big point is, all right, back to some of the first papers we talked about, metacognitive skills, right? So I ask myself, am I using the right kind of prompts to take myself to Bloom's taxonomy levels 3, 4, and 5, so I can get up to those higher levels, so I can get up to analyzing, evaluating, creating, getting to the point where I'm learning at a level that allows me to bring more value to an organization. You know, I remember when Sean Stallings first came on with CWNP and Certitrek, he and I had our first meeting. And at the end of the meeting, he told me something that I hadn't really heard before. He said, I'm going to enjoy meeting with you, I can tell, because we're going to have L4 and L5 conversations. And I didn't even know what he meant by L4 and L5. I'd never heard it phrased that way before. Right. But what he was talking about was, we're talking at that higher level and getting into both strategic thinking as well as creative thinking. And he enjoyed having the ability to have that kind of conversation with someone. And that's exactly what I'm talking about here. How do you get the LLM to be that conversation partner for you? Mm-hmm. And it comes down to how you prompt it, because it's only going to do what you ask it to do, right? What are your thoughts?
No, I love it. That's honestly, you and I had a conversation about this around a week ago, and shared these papers. And obviously we share that passion as far as trying to research, see what's cutting edge, and refine and really get to those L4, L5 levels. But literally just in a week, I've seen a lot of good improvement in how I prompt and how I utilize different aspects of GPT's LLMs, as far as getting my cognitive understanding, like as I go through certain certifications, as I do different projects. I'm doing or giving it a persona, right? I think we've talked about that before. Mm-hmm. Letting it be that expert for you, but really going in as like a conversational, or like talked about debugging, saying, hey, here's where I've gotten to, here's this point, maybe doing a screenshot, maybe doing the video aspect, and then saying, from here, where would I go, and give me 2 or 3 different ways to do that. That's helped me a ton in building out different technology aspects. Again, that's something you've seen a lot of success with, right, Tom? As far as even writing a research paper, giving it that persona, and then breaking down how far you've gotten.
Yeah, absolutely, absolutely. And so here's the thing. Here's something interesting that just happened in the last week or two. So Claude, I'm not a huge fan of Claude AI, and the reason is I pay for, not the most expensive level access, but the $20 a month level access. And I pay for that for Claude, for Gemini, for ChatGPT, for Perplexity. So I've got like 4 or 5 of these. The thing I'm not too excited about Claude, and, somebody else loves it out there. That's fine. Good on you. But what I don't like is that if I really go at it hard and I'm interacting with it a lot, I run into the threshold for the best models that it has, the frontier models it offers. I run into that threshold sometimes within 15 minutes of using it.
Mm-hmm.
I can use Gemini all day,
Right,
and heavy, and I never run into any thresholds whatsoever. So it's very annoying to me that happens with Claude. But let me say the other side of it. Claude is probably closer to actually making money. or Anthropic specifically, because they're actually probably charging you what they need to charge you. Because let's be honest, Gemini, Google is not making any money with Gemini yet. OpenAI is not making any money with ChatGPT. I don't know for sure with Perplexity. I doubt they are, but most of these large language models, they're not making money. They're spending 10 times as much as they're making. That's the reality. I did some analysis, interestingly enough, had Claude do some analysis for me the other day. I said, when are the big frontier model companies going to get to the point where they don't start making a profit, but where they've made enough profit to get back all the money they've lost? Because right now they've lost billions and billions, hundreds of billions of dollars. So the question is, when do they start making a profit? And then how long after that will they have to be making a profit before they finally break even and they get back to zero? And with Claude's analysis, it came up with, looked at a bunch of reports and things like that, and it predicted that it could be as early as 2030, but some expect it to be as late as 2035. So in other words, some people are saying we could be 10 years away from these LLM companies just getting back to zero, being able to say, hey, we've existed for over a decade and we haven't made a dime. Don't you love us? That's the reality of what's going on with these frontier models right now. They're not making money because it's so expensive to train and then to offer what they have to offer. And in order to get people to use it, they can't charge what it actually is costing to provide it. Mm-hmm. They can't do that. Instead, they have to, what they have to do in these kind of tech startups is they have to predict over time, what can I eventually get the cost down to for providing this? And so what do I need to charge now just to be able to justify to continued investors they should keep investing based on the promise that one day they're going to make a killing, because eventually this amount that we're charging is going to make us a bunch of money. That's ultimately what they're doing, right? And right now, none of them are making money, and they're hoping to. Now, I will say there are some companies that use AI that are making money. Apparently, Lovable, if all the reports are true, is making money hand over fist right now. So apparently, Lovable's doing really well. So there are a few companies in the space that are making money, but the frontier models, they're not doing it. They're spending a lot of money, and they're about to spend a whole bunch more. Huge data center investments. Mm-hmm. Being deployed over the next couple of years. And so, yeah, we're a long way out from them making money. But one of the things about Claude that they did introduce is if you go into your, I believe it's in settings, and then capabilities, and then, yeah, right here, skills. So they've added this new thing. I don't know when they added it. I don't know if it was last week or the week before, because I don't really pay attention to the news on Claude as much because I don't use it as much. But they added these things called skills. And what is a skill? It's a repeatable, customizable instruction set that Claude can follow in any chat. If you click on Learn More, it takes you in here, and you can see you can create your own custom skills. It's basically a markdown file at minimum that tells Claude what to do. But I say at minimum because as you can see, if we go down further, this thing can include a directory structure that has the markdown file and then a subfolder called resources. That resources folder, it can have data in it. So it could be text files with data, it could be PDF files or something like that. It can have Python scripts in it that you literally want Claude to run. It will run the Python script, right? So it can become pretty powerful as to what it will actually do. And the ability to build these skills out has got a lot of people very excited. But as soon as I saw it, I said, this is funny because I've been doing this for months. I just have been doing it through kind of a back door. And that's my whole webinar on Friday is going to be devoted to showing people how to do this in any AI provider, any LLM provider that gives you a kind of canvas. So like ChatGPT has a canvas, Gemini has a canvas, and so forth. So I'm going to be showing you on Friday, well, not you per se, but anyone who's watching, how to do this and how to get the AI, therefore, to have programmable logic available in the process. So this is one of the limitations that we've had with GPTs, with Gemini gems, and what Claude is fixing with their skills is that with the gems and the GPTs, all you can really do is give it some unique knowledge like PDFs and things like that, and then give it a prompt. And so that's about all you could do. What skills here with Claude is doing is saying, now we're going to give you the ability to run Python code. We're going to give you the ability, therefore, to have logic, programming logic in how your custom AI engine will work. And that's what they're calling a skill. But check this out. And this is our sneak peek about Friday's webinar. I'm going to get into this on Friday in more detail, but I've got here this little thing called the IEEE 29148 requirements tracker. Okay. This is a Gemini Canvas project. It is really just HTML code. Excuse me. If you take a look at the code here, you can see it's an HTML file. It's got some JavaScript in it. But one of the key things is that this JavaScript uses AI. And I'm not going to get into heavy duty detail on it today. But right here, you notice I just loaded this up in the blink of an eye, right? I did not have to give it a prompt to create it because there was a historical prompt that already created it. And so I just clicked on a pinned prompt over here to bring it up. And now I can click on import project and I can actually import an already existing project. Look at this. Oh, it's got these pretty colors. We got green and blue and purple and red and yellow. And we've got, it looks like requirement statements here and sets of requirements, one for a main campus Wi-Fi network, one for a remote site Wi-Fi network. And look at these interesting buttons. This one says verify set with Gemini, and this one says verify with Gemini. I wonder what that does. Well, let's click on it and see what it does. It says Gemini verification results. What it's going to do is it's going to look at that requirement statement, and then it's going to come back and tell me, according to IEEE 29148-2018, is that a good requirement statement? And we can see here that it went through and it evaluated it, and it's giving me some feedback and giving me suggestions for improvement, which in this case, it's a minor addition because it's already a pretty good statement. But if I write a bad statement, so like if we come down here and let's say we'll add a new requirement and we'll just call this Wi-Fi outdoor coverage. And for my statement, I'll say we need coverage outside the building. And that's it. We'll save that. And then I'll say verify with Gemini. And so what it's doing is it's doing an API call to the large language model and asking it to verify that. But it's passing to it the requirements that are in IEEE 29148-2018. So necessary, appropriate, unambiguous, complete, singular, feasible. So it's got all of that being fed into it with descriptions of what those things are. So if we go over here to code, I think I've already passed up. What? Maybe not. Yeah, here we go. Here's our prompt. So notice that necessary defines an essential capability. Appropriate, the level of detail is right for the entity level. Avoids implementation detail, da, da, da. So it goes all through that. Here's the thing. I didn't even type in this prompt. I just uploaded the PDF of the requirements standard and told it to figure out what the prompt needed to be. And it built all of this code for me. But the key is, this is exactly the kind of thing you do with Claude Skills. I've been doing this literally for over 6 months now. And only recently did it dawn on me that maybe most people don't know that you can do this. And the key is that right here, when it's making the API call, actually it's further down, right here when it's making the API call, you can see right there, it has an API key constant and it's empty. There's no API key in there. And I can run this again and again and again and again 10,000 times in a day. It just keeps on working and I never have to pay anything for the API. Because the way Gemini is treating it is, you're in the chat interface. You've paid to have pro level access to this. So you could copy and paste the requirement in, and also the PDF. And in other words, you could do all this stuff. So why wouldn't I just let the API run without cost? And that's effectively what it's doing. So it's running the API without cost. Now it's giving me this weird format structure here, because it's trying to format this like a table response. And I could tweak it and change it to fix some of that stuff if I wanted to. But the point is that I'm taking advantage of the API for this. And I've got a feature here to save it and load it. I'll cover all that on Friday. So right now I'm just kind of giving you a sneak peek of what can be done with this kind of thing. And now check this out. If I go over here now, I've got this other one here. It says visualize data. And it says, okay, this is the requirements dashboard, import your data. So what I'm going to do is I'm literally going to report that exact same data I was using in the other app. Now, all of a sudden, I've got a completely different app from the tracking perspective, where I can view all of the requirement statements that have been generated by that other tool. And I can view them in a hierarchical view like this. I can view it in a board. I can view it in a mind map that's expandable and collapsible. I can view it in a data table that's filterable. So I can filter to the remote site, for example. And I can view a dependency matrix, which basically says that requirements depend on other requirements. And what this is going to do is look at my requirement set and use AI to generate a traceability matrix so I can see what requirements depend on other requirements. And that was an API call right there to the Gemini API. And we can see then the dependencies here. If I go back to the hierarchical view, if I come in here, I said, hey, I want you to add a feature where you give technical guidance for the requirement statement. So like if we take this Wi-Fi performance, the network shall provide an average of 2 megabits per second IP layer throughput per device concurrently connected at peak load times, measured as a maximum of 200 devices connected to each API. All right. So if I click on guidance, it does a Gemini API call, and it has prompted it with certain things, whatever, in order to give me technical guidance on how I'm going to be able to implement and meet that requirement of 2 megabits per second at the IP layer. And so it's got it in here, what it specifies, how you're going to accomplish this, what the technical issues are that you're going to face along the way, et cetera, et cetera. And so all of that information provided to me with just the click of a button, specific to that requirement. So that's the point. The point is, what I've got here is programming logic, custom knowledge base, and a visual interface to access everything, which goes beyond what Claude Skills give you. So the point is, I'm getting everything Claude Skills can do. I've been able to do this for months, and it's just built into Gemini, and a lot of people don't know it, but similar things are in ChatGPT and in other tools as well. It's just it's figuring out how to use it to your best advantage. So we'll get into the whole process on Friday's webinar about how to build something like this and ideas of things that you might build and might benefit from creating. We'll talk about that then. Have you had a chance to play with any of these at all?
Yeah, I messed around a little bit with the Gemini, within Perplexity. They've got that home lab set up. But yeah, any GPT, any AI that has that Canvas feature, it's great. Pops up for you, and like you said, most of them you don't have to use an API key, so you can plug and play, and you've got that chat interface. You can make adjustments. Yeah, I'm a big fan.
And that's the thing. So what most people do is they take the code, they download it, then they put in their API key, and then they run it, and they're having to pay every time they run it.
Right.
But if you just leave it as a pinned chat in here in your canvas, then you're not having to pay for all those API calls, and you're using your custom built tool that you created yourself to do whatever it is you want to do. Pretty cool concept.
Yeah, I'm a big fan, especially from that learning aspect, right? You can get that immediate feedback. You can have that kind of dialogue with it, and
yeah,
have to leave. Love it.
Well, let's move toward wrap up and talk a little bit about the news. Samsung hit with a $500 million verdict over wireless communication patents.
Mm-hmm.
Of course, Samsung says it's all false. It's not true.
It's not
Patents aren't viable.
How about it, Texas? Can't be true.
Of course, because that's what I would say too if I was just found to be in violation of someone else's patents. You know, this is an issue that comes up in the technology space again and again. It has been a heated debate for decades now, actually. Can you patent a conceptual process, even if it can be defined mathematically, and when implemented, it does something in the real world? So what I mean by that is, so here what we're dealing with is some specific things. As you can see, let's see here. Do they say it in the Reuters one? I know it's in the other post that they do mention it a bit. Research conducted by defense contractor, not involved in the case.
Yeah, base systems.
I don't think this one is telling me a whole lot about it.
Yeah, it was not as much.
But the other one, if you look at it in more detail, it basically has to do with the way in which MIMO is deployed. So this is something that does happen in the real world. But it doesn't necessarily, some of these trademarks they're referring to here, or patents rather, they don't necessarily patent like a specific chip design. They patent a way in which you use radio frequency. And so without even having to ever build a real product that does it, they've patented using it that way so that then they can hold people liable for doing that, even though they didn't necessarily have to build a chip. So that's kind of where the big debate comes in. The debate is you patent a way to do something without ever physically implementing it being done in that way. And so now you have the right to keep other people from actually doing what you've never actually done. And I'm oversimplifying it, but that's the basic crux behind why there's been a debate over whether these patents should even be allowed to be created and all of these kinds of things. But the historic rule has been that the patent can be created, and if so, then it can be infringed upon. Mm-hmm. And that's a pretty pricey one there for sure.
I'll hit you. That's it. And just how enforceable it is. That's always
Yeah, and that's the thing too. Just because there's been a verdict does not mean that it won't be contested, and it may or may not stand in the end. No one who wins a settlement ever gets that settlement in any reasonable time frame. Well, unless it's a $10 settlement, then they can hand it to them on the way out of the courtroom.
That's what it might end up being. Well, yeah,
it's like what are those shows like Judge Judy? Those kind of shows. Maybe on a show like that you'll get your settlement on your way out of the courtroom. But
right.
I've even heard on some of those shows that the court actually pays whatever the penalty is in order to get people to come on the show.
Oh yeah.
And I've even seen that some of it is just actors and they're not even real cases.
Yeah. I've seen those little small documentaries. Sometimes they bring the same people back on.
I liked the judge. I think he was in Connecticut or Rhode Island, maybe. He died recently. I was really sad to see that he died. He was like this 80-something-year-old judge that was still on the bench, and he was just always so nice to people that came into his courtroom. I mean, obviously, as long as they were respectful and nice and had a lot of fun with people, but I forget his name. I used to love to watch his video clips.
know exactly what you're talking about. Yeah, you always seem to have compassion, which we can appreciate.
Oh man, I would have loved, because most of them were traffic type things, and I would have loved to have had a judge with some compassion with my early traffic violations when I was younger.
Who wouldn't?
Yeah, TP-Link hits a critical milestone in breakthrough Wi-Fi 8 trials. So what they're basically saying is, hey, we're on our way. Wi-Fi 8 is coming along, and we've actually TP-Link has actually done some tests with actual connections, actual data throughput and beacon communications using Wi-Fi 8. So the next is technically here. I mean, we can't buy it and implement it today, but it's technically here. There have been test labs, and of course, we know that it's not just TP-Link that's doing this. They're a fairly small player in comparison to the Ciscos of the world and folks like that. So we know that it's well on its way, and we'll be seeing those products coming to market probably in the next 12 to 18 months. Never-ending thing, it looks like.
Yeah, I thought it was interesting how they're aiming for reliability with this one, not as much throughput.
That's actually a good point, and so we've alternated the last couple times. So we had 802.11 HT was 802.11n. That was HT, high throughput.
Gotcha.
And then the next thing we had was 802.11 AC, which was very high throughput.
Mm-hmm.
So we went from fast to very fast. And then the next one was actually called HE, high efficiency. And so the focus of 802.11ax was not so much on, hey, let's make it faster. It was on, let's make it more efficient. Although it was making it faster at the same time. And then the next one was EHT, extremely high throughput. And so that's, what we're calling Wi-Fi 7. And that is all about getting faster again. And now we're cycling back. Okay, now let's go back to reliability and so forth. So there's always this thing where we come back to faster. There's actually a video of me at a conference back in like 2018 or something like that. And when 802.11ac came out, of course, it was called very high throughput. And I said, okay, what's the next one going to be? Very, very high throughput. And after that, will it be very, very, very high throughput? And where does this stuff go? Well, interestingly enough, the next one that focused on speed went from very high throughput to extremely high throughput. So now you have to wonder what does come for Wi-Fi 9. I mean, what is that? What are they going to call it now? Uber high throughput? I mean, what's the next level above extremely high throughput?
I don't know. It's gonna be like Fast and Furious movies at this point. Just more furious, more fast.
I think we need to start borrowing from the wired world. What they did is they said, okay, you've got 10 megabits per second. Okay, now you got 100 megabits per second. All right, now you've got a gigabit per second, and then 10 gig per second, and then 40 gig per second, etc. Let's just let that be the focus instead of these phrases that are meaningless. Very high throughput, extremely high throughput. Let's just call it 100 gig Wi-Fi,
right? Make it base 10. It's always
or 40 gig Wi-Fi or whatever. It would make more sense. At least we have something in the name that is telling us something about it.
Mm-hmm.
All right, we've got a Verizon outage that hit New Jersey, New York City, other parts of the U.S. Today, during the day of this live stream, we had a big AWS outage.
It's kind of a harbinger.
And I think these things are a good reminder to us, of the need for redundancy. Because the reality is that if you're depending on one service provider for whatever it is that you're doing, you're probably going to have problems. It's that simple. Because you're depending on their resiliency in their network being all the resiliency you'll ever need. And you know what? That's not a bad thing when it's your home internet. But what about when it's a manufacturing environment with 1,500 IoT devices that connect to a cloud provider?
Mm-hmm.
And so you're just relying on your ISP. Maybe you need Verizon or someone like them as a backup. 5G is your backhaul. So your backup backhaul. So you've got some other ISP that you're normally using to get to the cloud. Maybe you should have a second one. Yes, it might be a little slower, but you've got another backup through another provider. If we're going to end up, dealing with mission critical things with the cloud involved in it, here we have, within just a couple weeks time frame, a major network provider outage and then a major cloud provider outage, obviously telling us that we need redundancy and backup that we're planning for. And we're not just leaving it in the hands of a service provider and trusting that they're going to be able to do it for us. Hey, they can give us an SLA, and maybe they have to give us some reduced fee for the next pay period or something because of the outage. But that doesn't help me right now while the outage is going on. The only thing that's going to help me there is me having my own solutions. That's just my 2 cents.
Yeah, it's just good engineering. I mean, especially you think about a hospital or something that's critical to that. Like things have to work. Yeah, or heck, just going to the grocery store paying for things. Yeah, I'm sure we've all been there. Like, do you carry cash anymore, Tom? I know I don't. Like, if those credit card machines go down, I can't pay for anything.
I actually do carry cash. Let me tell you why.
Yeah, that's smart.
That's
your backup. That's your redundancy.
No, the only reason I carry cash is because I drive to Ohio every few weeks or months, depending. And there's a toll stretch across West Virginia where I have to pay tolls. I know. And that's the only area I drive where I ever pay tolls. And so I use cash for that. So I almost always have a couple dollars left in my wallet because of the last time I went through the tolls. But that's the only time. So I stop at an ATM, I get cash before I go through the tolls. And then there's always some cash left over because of the tolls that lingers on in my wallet forever because I never think to use the cash for anything. All right. So the only other two things that we have here is a 5G news and some there was a nice little white screen from my browser. And then Spectrum showcasing 10 gigabits per second Wi-Fi. Those links are in the post. You can check those out. Our monthly featured podcast this month, I'm just going to tell you a little bit about it because it's got to be a really good podcast. It has to be because they had me on there to talk about CNAE a few weeks ago. So it's got to be a good one. But seriously, though, it's one of them that I listen to regularly. And it's Heavy Wireless. This is a podcast that's hosted by Keith Parsons. And he gets on people from different vendors, different experts in the industry and so forth to talk about things related to wireless. One of those podcasts that you're going to get some good technical information every time you watch. So that's this month's featured podcast. And before we wrap things up for the day, Jonathan, got anything you'd like to talk about as a closing thought? Anything about anything we've talked about or haven't talked about? What's your sage advice for everybody in the world this month?
Sage advice. Oh, man. Well, no, I just really always enjoy talking to you, Tom, getting on here and learning, right? I think it's something we all kind of get away from, and it's good to just have a conversation between you and me, even if it's digitally. Community's big aspect of any learning. You can use all these tools, use all these LLMs and technology, but if you got the opportunity to talk to a Tom Carpenter, I suggest you do it. And just try and get a little better every day. So I think I'll leave with that. Just a little better every day. Use what you got. Reach out to your folks.
All right. Come here, Jax. Come here. Come here. Say hi to everybody. Get your little nose up there. Okay. I got his nose in the shot. That's as much as he'll let me do. He's being stubborn.
I'll take it.
Come here. Come here. Come here. Come on. Show off. Show everybody you're here. Come on. Come on. There you He's camera shy. Jax does not like to get on the camera. He likes to come over, stay off camera, and reach out and claw at my leg whenever I'm in meetings, whenever I'm trying to do webinars, but he won't come up into the camera shot for some reason. I don't know why. I'll have to figure that out. we'll get Jax on the show sometime so everybody can see him. All right, Jonathan. Well, thanks for joining with me. Great topics this month, and look forward to what's to come. And everybody remember, this Friday, 1 p.m. Eastern Standard Time, we're going to do the webinar where I'm going to go through helping you get more technical depth out of your generative AI usage so that you can get more value as an IT professional out of those systems. And we'll talk about that then. Other than that, thanks everybody. And I hope everybody has a good month until the next one.
Absolutely.